Very good morning, everyone. My name is Cordelia Ipinge. I'm a project coordinator for the SADC Renewable Energy Entrepreneurship Support Facility. Welcome to our technical training session as part of the facility's capacity building. I'll now hand over the floor to KGRTC. Thank you.
Cornelia, good morning and good morning everyone, and welcome to the workshop. And thank you very much, Cornelia, for passing on the floor. My name is Brian Makungo, and will be the moderator, facilitator, if you wish, for this program launch. And at this stage, I wish to, thank our sponsors for the workshop, Sakri and Irena, indeed, for making available the financing and all the logistics for procurement related to putting up this workshop. We also hasten to mention that the Kafue Gorge Regional Training Center, which is a subsidiary organization of SADC, like Sakri, is the ones facilitating the workshop, and all the team of presenters. In fact, let me say facilitators and not presenters. All the facilitators for the training sessions are coming from Kafue Gorge Regional Training Center. We also want to thank the participants, from various SADC member states and representing the different, SMEs who are joined us, in this workshop. We know that a few more are still trying to log in, and my colleagues in the Secretariat will be assisting in that, in that regard. But we have, I think all of us have received the, the program and all the preliminary, issues, and some of our colleagues who made time yesterday did manage to walk through the platform and interact with some of our team members regarding accessibility to the learning platform that we are going to use throughout this workshop. This being the launch, we have a limited amount of time. I think all of us are eagerly waiting to dig into the workshop proceedings, but allow that the launch session is given, so that we have the right context and we have the expectations cleared, both from the participants as well as the sponsors. I think it's very important that we know what our expectations are, and we work towards that, so that we make and get maximum out of make maximum benefit out of the time that we are investing in this workshop. And so, ladies and gentlemen, without further ado, let me invite the remarks from Irena and Sakri, and I pass on the floor to my colleague at Sakri to lead us in that regard. Cornelia, the floor is yours again.
Thank you, Mr. Makungo. Thank you for that brief from KGRTC. I now hand over the floor to Mr. Kudapashin Lukula, the Executive Director at Sakri. Thank you.
Thank you so much, Cornelia. Thanks, Brian. Good morning to you all. I greet you under these challenging circumstances that we are in. We all are aware of the situation around us. That is the pandemic, the COVID pandemic, that is quite rampaging through the society, through our communities. So we sympathize and we share the trauma that our communities are facing. Anyway, despite that, I'm happy that you have braved this chilly weather, wherever you are from, maybe it's from the comfort of your homes or in the offices, to join this training session. So I'll start off by greetings to KGRTC Director, Mr. Kaela Kenneth Siame, to Brian and the entire staff at KGRTC, to my colleagues at IRENA, Benson Zay, Elizabeth Wanjuri, and the rest of the IRENA team who could be in this session. Thank you, and appreciate your support. I mean, this facility that we are running is possible thanks to the financial support and technical support from IRENA. But again, this training cannot be any training without you, the participants. So we welcome you, the participants, to this 3-week training session under the SADC Entrepreneurship Support Facility. This is a facility that was muted 3 years ago by IRENA and SACRI. And you may be asking why SACRI. As Brian has indicated, we are a subsidiary of the SADC, of the SADC organ. And here, SACRI was established in 2015 by the ministers responsible for energy. We're given a mandate to address 2 primary things, that is energy security and energy access, through the tapping into the abundant renewable energy resources and energy efficient technologies and services. You probably are aware, I mean, as SADC citizens, we're all aware that we are grappling with issues of energy security. We are still not energy secure as a region. So quite a number of countries still face load shedding or poor quality electricity supply, sometimes low voltages, and other aspects of low quality or poor quality electricity services. But also at the same time, we have quite a number of our population that still does not have access to clean, modern, and affordable energy services. So it is the background of this that then SADC, in its wisdom, then saw it fit to establish this center so that we are able to support the member states in addressing quite a number of challenges that they are facing in order for us to have universal access to electricity or modern energy services, as well as to have a secure supply of energy. We also have a mandate as SACRI to support the implementation of the regional strategy on renewable energy and energy efficiency called RESAP. This strategy is running from 2017 to 2030. On top of that, we as SACRI, in 2019, we developed a business plan which would guide us over a period of 3 years. And out of this business plan, we clearly highlighted that renewable energy, small to medium enterprises, has a significant role in promoting energy access, in deployment of renewable energy technologies, in job creation, and as we know that this will contribute overall to the economic development of the SADC region. So yes, indeed, we believe that you as SMEs who are still starting up will need that boost, that eventually we hope that you end up ticking the big project, ticking the box of the big projects. We are aware that you face quite a number of challenges, some of which include financial, obviously. We do not have access to capital. But also at the same time, we believe that money follows a good project. So what we want to do is through this facility, we want to help you impact or give you additional skills that will enable you to able to design and develop projects that then becomes much easier for you to access capital. So the SADC Renewable Energy Entrepreneurship Support Facility serves as a technical support and mentorship platform to address some of the challenges that we experience as entrepreneurs, specifically those challenges that are to do with strengthening your capacity to assess the business potentials for sustainable energy, to develop business plans which are very viable, and also that you may be able to access funding that is out there. Funding, as we know, comes in different forms, some of it being grants, repayable or non-repayable, some of it being loans. So the idea is that we capacitate you, that then you are able to access this funding. But also at the same time, we also want you to manage your businesses. We want businesses that are sustainable, that are successful. Furthermore, the facility also aims to increase the confidence of the financial institutions which you'll be approaching yourselves to seek for funding. We want these financial institutions so that they've comfort and they've confidence in the technologies, they've confidence in the business proposal that will be submitting to them. So there's a link. This facility is not only focusing on new entrepreneurs, but it is also looking at the financial sector, so that we're able to capacitate the financial sector. We'll bring the two of you together for the commonality of increasing, addressing energy access and energy security. And when coming to this training course, this course, which is on planning, design, and development of renewable energy projects, which is being facilitated by KJRTC, we've chosen 33 of you SMEs, and these are coming. You are coming from different countries. So far, we've got 10 countries, which is Botswana, Democratic Republic of Congo, Lesotho, Malawi, Mozambique, Namibia, South Africa, Tanzania, Zambia, and Zimbabwe. So as you can see, you're all coming from different countries. It is our hope that one day that we may have projects that are transboundary, that you, an entrepreneur in Malawi, can team up with an entrepreneur in South Africa, in Tanzania, and together they may develop a project with their counterparts in Zambia or Zimbabwe, or Congo for that matter, or Botswana. So this training workshop will build the capacity of you, the SMEs, in different technologies such as small hydropower, solar PV, solar thermal, concentrated solar power, wind, biogas, biomass. So the different topics that are to be covered include project planning, project conceptualization, scoping, technical procedures, and the like. Further details are going to be provided by my colleagues. So going forward, we also are looking at, so far in this particular course, this is a technical component. We expect that in the coming months, probably around September, then we're going to cover the commercial aspect of renewable energy. And again, we'll be looking at how we can bring in mentors that then can walk through with you in your journey to be successful entrepreneurs. So in conclusion, we urge you entrepreneurs that you can participate, you engage, you interact, share experiences. You have vast experience in this field. We want to tap into that experience, that this can be shared amongst yourselves. And as I said earlier on, we hope to have successful and sustainable businesses coming from this group of entrepreneurs. With that, I thank you. And in conclusion, I thank KJRTC and ARENA again for this collaboration, and finally yourselves as entrepreneurs. Thank you so much. Over to you, Cornelia.
Thank you very much, Mr. Ndrukula. I now hand over the floor to Mr. Benson Zay from IRENA. Thank you.
Yeah, thank you, Cornelia. Good morning, everyone. My name is Benson Zay. I'm a consultant with IRENA, and I'm involved in the implementation of the SADC entrepreneurship facility as well as other initiatives. Yeah, sorry, I'm not able to I'm not able to show myself on the screen. I don't know why. Maybe it's because of technology. But I'm delighted to welcome you to this first training workshop of the SADC Renewable Energy Entrepreneurship Facility for the second cohort of training and mentorship. And I'd like to thank you all for joining us today. I also take this opportunity to welcome Kafue Gorge Regional Training Center, our training facilitators. We are happy to work with you. We have worked well previously on the first technical training. Yeah, so the International Renewable Energy Agents promote a widespread and increased adoption and sustainable use of all forms of renewable. We support countries in their transition to a sustainable energy future through various programs. Renewable Energy Entrepreneurship Support Facility is one of our initiatives, and it is aimed at enhancing the capacity of renewable energy, small and medium-sized entrepreneurs. We are implementing this facility in partnership with the SACRI in the SADC region. This first training workshop focused on technical aspects derived from the request for assistance by SMEs. It's a pity that we are conducting this training virtually. We would have wanted to have a physical training where there could be more interactions, there could be hands-on practicals, field visits, and there won't be any network challenges. But due to the COVID pandemic, it's not possible. But globally, we have witnessed the tragic loss of life and the continued economic uncertainty because of the pandemic. This current crisis underscores the need for reliable, sustainable, affordable energy access, and the renewable energy entrepreneurs are best positioned to address these energy gaps when provided with the support. So the facility is just to give you wings so that you as SMEs, you can fly. Right. IRENA's Global Renewable Energy Outlook of 2020 report reviewed that Africa could meet about 23% of all its energy needs from renewable energy by 2030. And the transformation would yield positive impacts in terms of GDP gains, in terms of employment and welfare gains. So we foresee about 2 million additional green jobs being created in sub-Saharan Africa only. So our SMEs should also contribute. So for them to contribute, they need to be assisted. So now when you look at the SADC region, you've got vast renewable energy potential, and there's still a lot to be done to drive this potential into deployment of renewable energy SMEs due to a number of challenges. So the facility, is what Kuda has said, is assisting to address some of these challenges through training, mentorship, creating linkages with financial institutions. And lastly, I just want to reiterate what Kuda had said in terms of the need for SMEs to collaborate. So from our first cohort of training, the major challenge there is about accessing finance for project implementation. And most of the projects by SMEs, usually they are asking for a low amount. So most of the funding institutions, they provide much more than what is being requested. So there's need for you SMEs to just collaborate. So SMEs from South Africa, Botswana, Mozambique, Malawi, you just need to, and other countries, you just need to collaborate so that you can have a bigger project so that it will be easier for you to access finance. And lastly, I just wish you all the best during the training. And once again, I thank you for joining us for this workshop. So over to you, Cornelia.
Thank you very much, Mr. Zay, and thank you again, Mr. Ndukula, for those welcoming remarks and opening remarks. So now on our agenda, on the timetable, we have introduction of participants, and I see here that we're already over time. So I'll just quickly go through the different countries that we have, and I'll call on the name of the company, and one representative can kindly just introduce their, by introduction of their name, the two participants that are joining from each company. So to start off, I'll start with Botswana, Satso. Kindly just, can one individual kindly just introduce the team members? Thank you.
Good morning, how are you?
Good morning, yes, thank you. And we also encourage you to switch on your videos as you introduce yourselves.
Okay, my video is switched on, right?
Yes.
All right. I'm Pelonta Mapula. I'm with my colleague Samarang Gombo from Botswana, Solar World, Botswana.
Thank you.
Thank you.
Satso?
Yes, yeah, I'm Msaope Mtamba, representing Satso IT Solutions.
Thank you. Next is the Democratic Republic of Congo, Tech Power Services. And kindly switch on your video.
Hello, hi everyone. Actually, it's a pleasure to be part of this. My name is Lohose Joe Daluponja. I'm speaking from the Democratic Republic of Congo. I work with a company called Tech Power Services, as Cornelia highlighted. Thank you and nice to be here. So we are together with my colleagues, Parfait.
Thank you, Joseph. And over to Settle International from DRC. I don't see the representative here. Oh, then to Lesotho, Seko. That's Seko. Yes. We cannot hear you in case you're speaking. Okay, I think Sakoy, we have an internet problem there, so we can come back to you later. Then over to Malawi, we have Green Belt Energy. Malawi, Green Belt Energy.
So Green Belt Energy is actually from Zambia. Jane Nakasam. I'm Jane Nakasam, and I'm the co-founder of Green Belt Energy. I am together with Mr. Mulenga Malama, and we are excited to be part of this training facility. Thank you very much for the opportunity.
Thank you. Tawonga. Okay, over to Green Impact.
Hello everyone, I'm Chisomo Jinkande, representing Green Impact Technologies from Malawi. I'm with a friend, Joyce Kwesa. Thank you.
Thank you. Then over to Quapro. Quapro, Mr. Banda, are you here? Okay, then we moved over to Namibia. Okay, before that, Mozambique, Africa Energy Services. Mozambique. Okay, I don't think they are here yet. Then over to Namibia, Onganga.
Morning, Linus. My colleague cannot able to join, so my name is Linus from Onganga Energy.
Thank you.
Thank you.
Ochongava. Ochongava Energy. Yes.
Good morning to everyone. My name is Julia. I'm going to be joining with my colleague Longeni. Thank you for the invite.
Thank you. I encourage you to switch on your videos so that we see you. Over to Tati Sola. Tati. Okay, over to geothermal.
Okay.
Yes. Nakanyala, you can go first. You're from Tati. Need to unmute your mic. Okay, over to geothermal. Neville. Okay, I see Charity is from Tati and her mic is on, but we cannot hear her.
Oh, okay. Good morning,
Yes.
everyone. Yeah, my name is Charity. I'm from Tati Sola. I'm here with my colleague, Sakias Nakanya.
Thank you. Over to Column Trading Group, Namibia.
Yes, good morning, everyone. I'm Edward Chefeni from Kosovo. I'm here joining you with
Okay, thank you, Shafeni. Your network is not stable, but we heard you. Thank you. And we move over to South Africa. Yes, South Africa, we have Zanzi Solar.
Hi, hello everyone. Trevor here. I'm joined with my colleague Edward Mello. We're from Zanzi Solar Solution, and thank you very much for this opportunity. And looking forward to the training. Thank you.
Thank you. Golden City, South Africa.
Hi, good morning.
Good morning.
Thank you for having us. My name is Naveen Naidu. I'm from Golden City Solar in Gauteng, Johannesburg, South Africa. We're working on the development of a utility scale solar project, and I'm joined by my colleague Alicia Governor, who is an environmentalist. We're looking forward to the program. Thank you.
Thank you. Over to Kumkani Group. Okay, over to GEC Solutions, Jack Solutions, Jack Solutions. Okay, a Green Energy Organization, South Africa. Okay, might not be here yet. And we have Getsatso, Jose Gatso. Apologies for the mispronunciation.
Okay, good morning, guys. It's pronounced Chaitso. Based in Rustenburg. So thank you very much, everybody. My name is Tuto. Unfortunately, my colleague from Nana couldn't join us today.
Thank you. Okay,
I am Cornelia.
Yes.
Sorry, I don't know what happened there. Hi, everyone. My name is Kosi. I'm representing Renewables for biomass energy. Thank you.
Thank you, Kosi. And over to Klahi Energy. I think they are not confirmed. Then we move over to Tanzania. We have Climate Action Network Tanzania. Any representative from there? Okay, then we move over to Zambia. Greenbelt Energy have introduced themselves already. Sunlink Energy. Sunlink Energy.
Good morning, everyone. I don't know, can you hear me?
Yes, we can hear you.
Great. Good morning, everyone. My name is Rainford Hachonga, and I am representing Sunlink Energy Solutions. We are based in Zambia, conducting small installations of small solar systems. Thank you.
Thank you. Over to CGM Power Group, Zambia.
Hello, good morning, everyone. My name is Faith Simula from CGM Power Group. I'm joined by my colleague Jason Mupeta. He's currently not with us. He'll be joining us soon. Thank you very much for having us.
Thank you. And then over to Zimbabwe. Yes, someone speaking?
Okay, my name is Chabuka Kawesha from CGM. We're currently working on a utility facility up to 50 megawatts here in Zambia. And I'm happy to be part of the team and of this interaction and to learn more. Thank you so much.
Thank you so much. Over to Zimbabwe, we have Joggies Woods.
Hello, good morning, everyone. My name is Lawrence Jongi. I'm the CEO of Joggies Woods. We are a company which is developing some off-grid solutions for smallholder farmers who are tobacco farmers, so that the load on forest resources is less. Thank you.
Thank you, Lawrence. Over to Green Tech Energy, Zimbabwe.
Okay, good morning, everyone. My name is Makarich Luke. I'm the founder for Green Tech Energy. We are operating from Zimbabwe, mainly on biogas systems installations. Today on the meeting, I'm also participating alongside Petros Makaikai, who is a co-founder for the organization. Thank you very much for having us.
Thank you. And over to Sustaenergy.
Okay, good morning, everyone. I am Fortunate Farirai. I'm representing Sustaenergy. With me here, I have Engineer Wisdom, my business partner. Thank you so much. Looking forward to benefit from this training. Thank you.
Thank you. Over to NITOR Engineering. Law Engineering. Apologies for the mispronunciation.
That's okay, Kaninia. Sorry, my camera, I just need to adjust the settings. My name is Farai Magombo. Sorry, Nicholas Magombo as well. It's the same. I represent Netlo Engineering. My partner, Mr. Lamo Magombo, is also trying to join, but he's having technical challenges at the moment. It's an honor to be part of this program and would hope to learn and benefit quite a bit. Thank you.
Thank you very much, Nicholas. And the next company from Zimbabwe, Lawn Force Energy.
Hello, good morning. My name is Marvin Morimoga from Land Force Energy. We are a company which specializes in biogas as well as solar. With me in this training is Shingi Matutururu. Thank you very much.
Thank you very much. Just to note that there are two companies, Rosa Solar Stores from Zambia, and a Tanzanian Tasmer is unfortunately unable to join. They're sending their apologies for the day, but those are the different companies. So in case I've missed a to call on a company, please kindly give you the floor now, just in case I've missed that.
Hello, good morning, everyone. This is.
Good morning.
Hello.
Yes.
Yes, this is Ncheme Sokopane from Lesotho. Good morning from the cold mountain of Lesotho. I'm here with my partner, representing Soho Technologies. Thank you very much for the opportunity.
Thank you very much. If there's no other person that we have missed out.
Cornelia, it's me.
Yes. Oh, apologies. I was going to get to that. Yes.
Oh, okay. Should
Yes,
continue now?
yes, you can continue now.
All right. My name is Bongile Mavimbela from the SADC Secretariat. I'm in the Environment and Climate Change Unit, and I'm grateful to be part of this training. Thank you.
Yes, thank you very much. I was just going to say that we have a member from the SADC Secretariat who's joining us, and she has introduced herself, as well as other colleagues from SACRI and IRENA. And I think for the interest of time, we've gone over 10 minutes, so I'll now hand over to KGRTC to proceed with the training. Thank you.
Cornelia, thank you very much, and dear participants, thank you very much for the introductions. In the interest of time, I will quickly call upon our director, Engineer Kaila Siame, to give the remarks and also launch this program. Director Siame, the floor is yours.
The CEO of SACRI, the representative from IRENA, fellow participants that are here. I know there's a lot of experiences, all of you from the different countries, having been given the backgrounds by SACRI. My remarks will be very short, looking at the time that we have spent so far, and requesting that each one of us as participants fully exhausts the various experts that KGRTC has put together to share with you the experiences and also ensuring that the modules that have been put together meet all your expectations. So I would like to challenge all of you that please exhaust these experts. I know all of you have got a lot of experiences, but let's not hold back. And it's also an opportunity for each one of us as we share the various experiences that we have. I look forward to getting your feedback, all of you, on the 29th, looking at the time that to spend together, and especially the aspects of what you would have obtained from the experiences that will be shared by our different consultants. I think with those few remarks, I would like to officially open the course and invite all of you to enjoy this program. Thank you, Brian.
Director, thank you very much. And this is the moment we all waited for, to have that declaration. This workshop is officially launched. The CEO from SACRI, Kuda, we're very grateful. I took notes on your comments that we're looking forward to joint ventures between among the SMEs in the SADC member states, so that we can undertake these projects from different countries and beyond our borders. I also took note from Irina in the remarks that this is cohort number 2, and it's part of a series of programs that we'll be running. Our quest was that we should have these courses conducted in a face-to-face environment, physical environment. We are all in one classroom, and we can take study tours, site visits, and then avoid all these network issues. Can you hear me? We spend half the time time we're not hearing each other. But I also took note on the aspect of financing that one thing we want to address in this workshop is to create capacity for SMEs to be able to, raise the financing required to undertake, renewable energy projects. And so this is what we'll be dealing with in the next, few days. Just reminding everyone that the workshop is only been launched and it's going to run for the next 9 days. We will be meeting a maximum of 8 hours per week. And so this week we expect to spend about 8 hours, 3 days on the most for each week. And yeah, because we are from Kafue Gorge Regional Training Center, we will, at this stage, want to remind the participants that you are in a training environment and you are going to be examined. And out of those examinations, you will be assessed as to be eligible to receive a certificate at the end of the training program. Now, this is not to scare anyone. Director Siami has indicated that in this workshop, we have a pool of experiences, good and bad experience, and would want to, bring that experience in this classroom environment, learn out of it and align it to the theme of our workshop. And remember, we are looking at the planning, design, and development of renewable energy projects in the context of our SADC. And remember, these projects are meant to be infrastructure, rather energy infrastructure, vehicles that are, as mentioned earlier by, Kuda, that we want to uplift the living conditions of the majority of our people who do not have access to clean and reliable energy, services. And your role as SMEs cannot be overemphasized. So I encourage you in the course of this workshop that you fully engage with the various, facilitators we're going to have in this workshop, and you bring your experiences, share them openly during the breakaway sessions that we are going to have. And so that said, let me mention that we will take a short break and quickly come back into the workshop to start with module number 1 on the concepts of renewable energy project planning. I must at this point now hand over to my colleague, Dean, from Kafue Gorge Regional Training Center, who in the main is the coordinator from KJRTC for this workshop. Dean, I invite you now to guide us how long the break will be and what we should do and what we should not do. Dean, I pass on to you.
Thank you very much, Mr. Makungo, Engineer Makungo. We can break for 5 minutes to allow you just stretch a bit and get 1 or 2 items, maybe a pen and paper, to be ready for module number 1. And when we return, we shall introduce the presenter for today, and maybe just give 1 or 2 indications on how we expect ourselves to be involved in the training as participants. So 5 minutes from now, we expect you back at 9:48. Thank you. Okay, welcome back. Technical team, I'll request that you put down the break poster. Andrew. Andrew, could you please put down the poster for the break? Thank you. Welcome back to all the SMEs and all officials from Sakri and Irina. I have few remarks to give regarding our participation in the program as SMEs, but before I do, just want to do a check for our first presenter that is on standby, Engineer Nurenda. Good morning.
Good morning, Mr. Msukwa. How are you?
Fine, fine, thank you.
Okay, thanks.
Yes. So let me just do 1 minute remarks to the SMEs. Just let me get a good morning from one SME just to make sure that you're getting me. Good morning, SMEs.
Good morning.
Good morning.
Thank you.
Good morning.
Thank you. Thank you so much.
Good
Yes.
morning.
Welcome. Thank you so much. Welcome. Yes, I will be helping you with coordinating the program, but I'll also be one of the presenters on one of the modules. But I would like to bring to your attention that the attendance for the training program will be taken note of. We will be able to download the attendance through Microsoft Teams. It gives us that facility, so we're able to know when you logged in and when you logged out. Then secondly, I'd like to mention that during the module presentations across the 9 days, there will be engagement with you in terms of group discussions or presenters asking you questions and asking for input and experiences on certain subjects, knowing that as KG artists, we are facilitating this training, but there could be special knowledge also coming from the participants that other SMEs could learn from. So we shall have knowledge coming from SME to other SMEs, as well as from KGRTC to participating SMEs. So it will really be a platform where we can all share and learn from each other. So there will be various aspects through which we could all participate and share knowledge. But we expect to have one formal essay that will be uploaded on the eCampus today, and it will be due for submission anytime up to the final week. The dates will show in the assessment. It's a short essay on a renewable energy topic. There are various options for you to choose one that you can respond to. Then further, I'd like to mention that at the end of the course, there will be a training evaluation by participants, which you yourselves, a tool that you use to give feedback on the training program. This will be done through a web-based short evaluation form just for you to respond and grade the training, how it went. For purposes of our continuous improvement as KGRTs, we run an ISO 9001 quality management system. The chat function is available as the proceedings are going on through the training program. You can write some questions or just share some information, some ideas and knowledge through the chat function, apart from the verbal opportunity to be given to speak. Also want to mention that Microsoft Teams has a facility for you to raise a hand. So there's an icon for chat function. There's also next to it an icon for raising your hand. Then during the time that the trainer would open up for maybe a question and answer session, you could use that so that he sees your hand, then call upon you to ask your question or make your contribution. Then after you're done, you lower your hand by clicking at the same icon. The trainer will provide for question and answer sessions regularly along the presentation, but where a pertinent clarification must be made, you could always maybe raise your hand or where possible, turn on your mic and ask a question. I think those are the few remarks I wanted to mention. There will be questions, but we'll keep interacting at different intervals as we go to the breaks. We'll be following the timetable for the breaks. I'll call now quickly the presenter for module number 1. Engineer Elvis Nyirenda, you begin by introducing yourself and then also carrying along with the training. Thank you very much. Engineer Nyirenda.
Thank you so much, Mr. Musukwa. Am I visible to everyone, all the participants?
Yes, we can see you. I can see you at least.
Okay. Thank you so much, and let me welcome you all to this training in renewable energy. And as you have heard, my name is Elvis Nyirenda. I'm currently working with ZESCO as a senior renewable energy engineer, as well as a consultant for the integrated resource planning for Zambia. Zambia is carrying out the transitioning studies for integrating renewable energy into our national grid. In the background, I've spent much of my time working for ZESCO as an engineer. Started as a junior engineer working for an hydropower plant for over 6 years, and then I did some studies, a master's in renewable energy at Dalarna University in Sweden. And then when I came back, I joined Renewable Energy Department, still with ZESCO. So in a nutshell, that's a summary of the background of my academic experiences and my work experiences. Right now, I'll share my screen to begin Module 1 presentations. Are we all able to see the screen?
Yes, we can.
Okay, thank you so much. Introductions have already been made. I will jump a few slides and then I'll start with Module 1. So this morning we'll look at the concepts of renewable energy planning. What does it take for somebody? What experiences or what knowledge does that person needs to have for him or her to carry out? Or if it's an organization, I know we have so many SMEs in this workshop, which is very good. So what to take for you to start planning for renewable energies, that's what we're going to look at. Then the contents, we have up to F, that is 6 points. We'll look at the sources of renewable energy and their applications, then also look at the plannings, including the policies which encompasses renewable energy projects. Then also look at integration and the impact survey, including the studies that need to be undertaken, especially for grid-connected systems. Yeah. Then tariff design, what constitutes the tariff, how are the negotiations need to be done for you to achieve at a reputable and what is called the cost-reflective tariff for you in order for your project to be successful. Then also look at the services for large scale. These are utility scale projects for solar PV, photovoltaics, which we're also going to look at. Then we'll look at the effective engagements strategies. This is very, very important, especially for the success of the project, because stakeholder engagement, when you are just starting the project, is very, very cardinal for the success of the project. So in a nutshell, this is what to look at. Then the key course objectives. By the end of this course, we should be able to know that you, the participants, should be able to be equipped with the knowledge and the skills for the best practices on the planning and the development of renewable energy projects. That's a very, very key. At least at the end of this course, these need to be met. Then the learning objective. At the end of this project, you need to make sure that you apply your skills for the concepts of renewable energy planning. You should be able to know where exactly do you need to do your project, how do you need to do the project, how do you achieve the benefits from that project that you want to have. Then now begin with the sources. There are so many sources of renewable energy projects, and I must say this, I shouldn't be speaking alone. So in the background, I'll be asking questions. So our facilitator, Mr. Musukwa, if somebody raises a hand, please let us know and let us point at the participant to quickly ask the question, and then we'll be able to come in. Renewable energy sources, these I can say are natural sources or the processes that are constantly being replenished. These sources include the following: water. We know, especially within the SADC region, we are vested with quite a number of water bodies, reservoirs, man-made, the lakes, including the rivers, which can be used for the production of electricity using hydro. Hydro has been one of the dominant energy projects which has been done within the Southern African region because of those resource materials. Waste materials, agriculture materials, forest reserves, animal dung, all these projects, the food waste are very much important. So these are some of the sources. Before I move into the other sources, can anybody give me an idea of probably another
Good morning, all. Kindly hold. I think the facilitator has been kicked out of the meeting due to his connectivity, but he should be back with us shortly, so kindly hold. Thank you. Okay, and Emmanuel, we've seen your hand up, and Edward, kindly keep them up, and as soon as he's back, we'll address that. Thank you.
Hello, Andrew. Andrew, can you hear me?
Andrew's on
Hello,
another
yes, I can
call.
get you.
Just a minute, he'll get back to you.
Okay.
Hello, I can get you, Edward.
Okay, yes. No, for me, it was just an input regarding the lessons as we are going on. That for the colleagues, at least who have access to the laptop, perhaps they can download or open the PPT. Is actually available for those who perhaps haven't opened it
Oh, yes,
yet.
yes. That's a great contribution, Edward. So for those that have already signed up for the eCampus, I believe more than 50% of you have actually signed up and registered fully for the eCampus. We have today's presentation. It's up on it's in the first module when you get to the course. Like I explained yesterday on how to go about the eCampus, you can access all files, all the training materials from the specific course that has been you've been added to. So thanks for that one, Edward. I think it's very useful. And we will have a session where we'll go through the eCampus again later on after the class. Thank you, Edward.
It's all good.
Cornelia, you have a hand up?
Yes, I was just, if maybe we can go through the eCampus platform now while we wait for the facilitator, just in case it might take time.
Oh, sure. I think that's a good opportunity. Thank you.
Thank you.
Andrew? Andrew?
Okay. Yes, I get you, Mr. Msukwa. We will do just that right now. And, I'm just trying to get to open my eCampus so that I can share with everyone. I can share my screen with everyone. Okay, so good morning once again, everyone. I'm going to go through the eCampus. My name is Andrew, and I'll be assisting you with all technical needs during this program. I believe everyone by now has received an email from KJRTC asking you to activate your account on the KJRTC eCampus. So we will be using two digital platforms during this training, and that's the Microsoft Teams, which is the teleconferencing app that will be used during this during the training sessions, the live training sessions, and the KJRTC eCampus will be used for all course documentations. So you'll be able to access all your course materials from the KJRTC eCampus, which is a cloud-based system. So for now, I will begin to share my screen, and I hope I would like to confirm if everyone can see my screen as I'm sharing it right now. Please confirm with me if you can see my screen right now so that we are all on the same page. If one or two people can confirm, that would be better.
Okay.
We can see it.
Hello? Hello?
We can see it.
You can see it. Okay, great. Okay, so I'll proceed. Kindly mute your mics. I will proceed with sharing the eCampus screen. But to start with, I think it would be important for us to just go through a document, a guideline document of how you can access the KJRTC eCampus. So to access the KJRTC eCampus, you're supposed to be registered, a registered user by us, and by now we have registered all the participants. If there is a case where you haven't been received an email notifying you that an account has been generated on your behalf. Please do let me know after this session, and we'll be able to assist you in order for you to access the KJRTC eCampus. So this is an example of an email that you're supposed to receive. It's actually a notification informing you that your account has been generated by us for the eCampus. So the three basic and major things you're supposed to take note of are actually your username, the password, and the eCampus link. So for the username, it would actually be your first name, your last name, or organization name. And for the password, it will be computer generated. So you will need to copy this password. Please note that you need to copy it and not type it in manually when logging in, because in many cases, people do miss certain characters that are computer generated, such as hashtags, etc. So please do take note of your username, copy the password, and follow the link. So once you follow the link, you will land to the KJRTC website. Let me just go to my eCampus right now. Okay. So once you follow that link I just showed you, the one that will be in your email, it should take you to the page that's loading up right now. So like I mentioned, please always take note of your username and copy the password instead of typing it in manually, because when you follow the link below, it will lead you to a login panel. So that login panel needs the username and the password. So for the username, it's something you can take note of, memorize, but for password, you need to copy it and paste it in. So this is the page that will pop up. This is a login panel that will come through after following that link. So if, for example, this is my username and this is my password, but if we're going with that example, then the username would be Jen. But in this case, I'm using my personal account, so I will use my username and my user password. So I'll log in, and please note that at the first time of each login, you will be prompted to change your password. This is a security feature that's in place to just ensure that you are the only person accessing the platform. So once you change the password and use the characters that will be outlined, you will then access the eCampus, the KJRTC eCampus. Allow me to switch my screen right now in order for me to have a view that will be similar to yours. Okay, so once you land on the KJRTC eCampus, you will have a dashboard that will have a user banner. And this is basically something that will showcase that you are in the right place. For example, this is what you have. It will say upcoming courses 2021, and that's just a slide banner, and beneath it you have available courses. I have a number of courses, more than one, because I've taken part in a number of programs. But for your screen, you should have at least one to two or three programs, and among them, this should be the course that you should look out for. This is the planning, design, and development of renewable energy projects. This is a course that you've been enrolled for, so please do not follow any other course, because these tabs actually are courses themselves. These are the courses. So these are the courses on the portal, and the information you need, the course materials, is available once you access or once you follow the links on these courses. So when you hover over, you notice that my cursor changes, and this shows that it's a link actually. So when you click the course name, you should be able to access all course materials that are available for you during this training program. And you have your course timetable, links to the link to the meeting, to the live session meeting, which will be added shortly. The course modules for each and every day, and the recorded video sessions for each and every day as well. Like each live session will be recorded, and we will include those recorded sessions for revision sake. So, for example, if you want to access the materials on the eCampus, I should mention that this is a click and browse functional dashboard. So once you hover over each and every item you need, it will actually give you the cursor will change to showcase that it's a link, it's an active link, and you have to click in order to access what you need. So for example, if we need to access the training timetable, we would hover over, click, and then our timetable will load up. So it's a click and browse functional based dashboard, like I said. So as you can see, it's just that my internet is a bit slow right now, but the timetable is loading up and we should have it within a few seconds from now. Yes, sir?
Andrew?
Yes, sir, can you get me?
Our trainer is back. Yes, Andrew.
He's back?
I can get you. Our trainer
Okay,
is
I'll
back.
just wind up.
Class.
Okay. All right. Okay. Just give me 3 minutes, 3 to 2 minutes. I'm winding up. So as you can see, this is the training timetable.
I'll give you 1 minute.
All right, sir. Okay. So you can see that this is accessible through just a click and browse system. And if we press our back button, we're back to the main dashboard. So for example, today's training module and PPT presentation can be found under this folder. So once you click, the folder will load up and you'll be able to access your PPT just like that. So we can click the PPT and there it goes, it downloads. Thank you very much. I think I'll end here and hope everyone has access to the eCampus. I'll hand over to Mr. Msukwa for now and have a great training session. I'll be available for any assistance like advice. Thank you. Mr. Msukwa, over to you, sir.
Thank you very much. Thank you, Andrew. Thank you very much. I'd like to welcome back Engineer Elvis Nyirenda. He had lost his internet connection. Engineer Nyirenda, you may please load back your PowerPoint, and it's now about 10:15. Please, maybe we can allow the class to break for 5 minutes around 10:40, 10:35, 10:40. Then we resume to proceed to complete the session. Thank you, Engineer Nyirenda.
Thank you so much. Am I audible?
Yes, you're audible.
Okay, let me just quickly share my screen. Are we able to see the screen?
Yes.
Okay. Sorry for what happened. I don't know what Liquid Telecoms are doing. Probably they lost the entire connectivity. I just noticed that on my Wi-Fi there was no connectivity. Can anybody please take me where we reached before I lost communication? Those who were following.
You asked the question. We were at the renewable energy sources, and we had asked a question.
Okay, so let's start with the question. What was the question? Please, the person that asked the question can go ahead, then we pick the question up.
No, it was actually you who were about to ask a question here.
Okay. Thank you so much. So my question was, yes, thank you so much.
Your question was, what are other types of sources of renewable energies? Because you mentioned the water and waste materials. So you asked the others types of renewable energy.
All right. And what were the answers?
Yeah, the answers, I think I can also add some, which is we can talk of the sun and the wind.
Okay. Thank you so much. So a follow-up question to that. Why do we think, especially solar, why is it making too much noise as one of the most resource that is being utilized in renewable energy? Anybody to answer that question?
It's clean and it's renewable.
Okay.
Hello?
Yes, we can get you.
is the global consumption of energy versus solar energy is available solar energy is about 6,000 times the global consumption. And also most of all the renewable energy sources, they get their sources from also the solar energy. So the solar energy is the source of all the energies.
Okay, thank you so much for that answer. Indeed, this is one of the most abundant resource. They say scientifically proven that apart from sand, which is most abundant in all the areas where we stay, solar is the next abundant natural energy resource which we are able to utilize. Similarly, wind follows. But what are some of the challenges that we see, especially when utilizing solar energy? Any answer? Then we move on quickly.
It is not stable. It is continuously fluctuating. The solar irradiance is always changing due to refraction in the atmosphere, due to also cloud cover. So it's continuously fluctuating. It's another challenge.
Okay.
Another issue is to do with storage,
yes.
the ability to store the energy and redirect it or reuse it.
Okay. That's very good. So we've talked about two most important things. We've seen that this sun energy, it's not always available. You will not have 100% available of this. Probably, if you are lucky, maybe our colleagues in Namibia, where the sun takes time to set, probably you have 7 to 8 hours maximum of daylight, peak sun hours. But in most cases, for example, in Zambia, during the winter periods, maybe 5, maximum 6 hours of sun periods. So meaning that you need to find ways in which now you can be able to harness this energy resource. Similarly, wind as well is not available all the time. And for wind, it's actually more variable than even solar. It's not constant at all. So technologies have kept evolving so that you can be able to harness these technologies so that you can be able to provide security of supply at all times. Then the other source is heat from the earth crust. I've seen within this workshop there are colleagues who are also doing geothermal, which is very interesting. So this heat from the earth crust is extracted using different technologies to provide either electricity or direct heat consumption. So now we can move on. We look at now the applications. So one of the great applications of renewable energy is for electricity production. Electricity production is very much important because this is what drives the machines in the industry. This is what provides revenue for GDP, revenue for economic growth. All this is because electricity is one of the major drivers for economic development. So within the electricity subsector, we've seen that hydro dominates as well as one of the largest renewable energy source, except hydro also has got its own challenges. Maybe I pose a question. Give me any of the challenges which you think hydro, besides it being stable, but it also has got one of the challenges, especially where electricity production is concerned. Anyone from the background, please.
Accessibility.
The availability of water might be a challenge. Continuous availability of water can be a challenge.
Okay, thank you so much. So we see that most of the renewable energy projects which are hydro, these are run off the river. So you see that if probably we are going towards the summer months, evaporation increases. As well, one challenge which we need to note is that as we are going in the next few years, you find that there is going to be huge population growth. Then huge population growth means that the water consumption is going to increase, as well as the need for water for agriculture is also going to increase. So meaning that water abstraction in these reservoirs and in these lakes and rivers is going to increase, which makes hydro also, although it's very attractive, but it also has got a posing challenge. Then apart from that, we see that when you are developing these plants, most of the plants are situated in areas where people are doing a living, economic benefits, for example, fishing. So you need to evacuate those people to find alternative areas where these people need to go. So you need to compensate. So compensation sums also a challenge. Also, hydro, another challenge. Let's hope we are taking few notes, because the facilitator, they will give you a test which you need to make sure that you pass. Hydro also, the cost of making an hydropower plant, it's also not cheap, and also it takes time for the plant to come up and start operating. So those are the major issues, challenges which comes with hydro. Another one is solar photovoltaic. Solar, we've talked about, it's not 100% available. Solar thermal. Anybody to give me probably one of the advantages of solar thermal power, which is concentrated solar thermal as compared to solar PV? I heard somebody talk about storage. Can someone elaborate more about that? Anyone, please? Anyone? Go ahead with a question or with an answer to the question I've posed.
Please repeat
Okay.
the question.
Yes. A lady can go
Okay.
on.
Okay, thank you so much. Like maybe from my little knowledge, I think when it comes to solar thermal, in terms of conversion efficiency, it is higher than solar PV, especially the solar thermal collectors.
Okay. Thank you so much on that one. Yes, indeed, solar thermal has got also the capability, especially of energy storage using molten salt. So solar thermal power, I think maybe in the next module we'll come and explain more. But in simple terms, I can tell you the two different types. One is a tower. I'm sure you've seen it. Those guys, especially the colleagues from South Africa, there is one near Drakensberg there. We've got a solar tower there, which is able to provide you with it. There's a central receiver system, which is able to be heated up to a temperature slightly over 800 degrees. And then that heat is able now to be converted into the steam, because you are able now to heat up the water, which later goes into the steam turbines for the electricity production. And then you can store that concentrated heat into what is called a kiln, where you find molten salt is there. Then this molten salt is able to store that heat energy at a temperature above 278 degrees, because any temperature less than 278 degrees, the molten salt solidifies and it can destroy the pipes in your power plant. So it's very much important, and that it, even when there is no sun, so meaning that you can do power production even during the night time. So that's a very much important phenomena, which is more advantageous to solar PV. But I should say that solar PV power plants, you can generate power anywhere, but solar thermal power plants are also site specific. One of the key considerations is that you need to place these solar plants in an area where you have direct irradiation. For example, in deserts. That's why you find most of these power plants are being built in deserts. Yeah, so that's one key advantage. Wind power plant is also very much important for electricity production. We've seen there is quite evolving. We've got offshore and onshore wind power, especially in Northern Europe, in countries like Sweden, Norway. They've exploited, especially, and also Greece. They've exploited huge sums of wind power. And actually, within our subsector, sub-Saharan Africa, we've seen that wind sites also have been sited For example, in our country, Zambia, a project was launched to cite which sites will be suitable for the production of wind power, because these are site-specific. Geothermal power plants also site-specific power plants. Similarly, both biomass and also biogas, you need to place them in an area where you know that the feedstocks or probably the prime energy products are always available, so that you can be able to provide constant electricity to satisfy the customers. The applications also, we continue. One of the applications of which I've already talked about it briefly is process heat production. Why do you think this process heat production is very, very much important to provide it directly to the customers? Any answer? An answer to the question. Let's be participating so that we enjoy the module.
I think for process heat, it's mostly to do with storage of the energy. Once produced, it must be utilized, and it will be very expensive to store that energy for later use. So that's why you have to locate it very close to where it must be used. That's what I think.
Okay. Yeah, that's a brilliant answer. You know, heat storage is very expensive as well. Then also, if you are using electricity to heat up probably the water for pharmaceutical industries or for the cleaning of minerals in the power plants after the process has been done to extract either the copper, the gold, if it's the silver, or our colleagues in Zimbabwe, the platinum, you may think that probably let me use the heat which is generated by electricity from either the coal power plant or a steam power plant or an hydropower plant. But your electricity bills will go up because you are producing heat using probably high consuming heaters, which will be able to be very much expensive for you to run your process. So that's very, very much important. We need to take note of that. Then some of the process heat production technologies, solar thermal, we've talked about solar collectors, then vacuum tube collectors. Another application of vacuum tube collectors in these are the domestic use of probably solar geysers. You find these flat plate collectors. These quite okay, not so much common within the sub-Saharan Africa, but technologies have started evolving using these flat plate collectors, because these you can heat up the water, for example, at a temperature which is above 300 degrees, which is very, very good. Especially you can convert, instead of having the traditional air conditioners, you can have a solar aircon. You can have a chiller plant, which will be able to provide you both heating and cooling, so that you can cut away the costs, especially which we spend on buying electricity for the customers. So for SMEs, this is your area. You can be able to explore this technology, and then you can locate the customers so that they can start consuming these projects. Geothermal extraction of heat using heat pumps. For if you get that heat, you can channel it, for example, direct into the systems for consumption as well as for providing heating and cooling. Biomass, you can extract the heat as well, so that you can be able to do it. And this technology is evolving very, very fast. We've seen, because as population is increasing, waste materials also, because man is also polluting the earth in terms of producing a lot of waste materials, as well as extracts from plants after farming has been done. Also, some of the remains from the forest reserves after wood has been processed, these are being collected, and then they are able to provide either gas, which they are consuming direct using for example, the gas stoves, as well as for lighting and for cooking. So you can see that this is making life very easy for a common human being. Then applications, this is just one of the pictures which I got to demonstrate a geothermal plant. So we've seen that it's metallic all over, and those they make use of especially silver. Silver is very expensive, aluminium, so that you don't waste so much heat. because you are producing the heat. Okay, maybe moderator, is it time for a short health break? If we can end here, or we can continue. Mr. Msukwa, are we there?
Yeah. Yes. Yeah, I think we can take a short break, but maybe the class might want to ask 1 or 2 questions. Then after that, we break for 5 minutes.
Okay. Questions, please.
Hello.
Yes, go ahead.
My hand was up when you were talking about electricity production for biomass. So I wanted to add a torrefication, which is something that they use to mix with coal when generating steam for electricity, and also for heat production, that you can actually mix the wood pellets, or you can mix any type of biomass with coal for less emissions.
Okay. Thank you for that huge contribution. Indeed, mixing two chemical properties, you increase actually the heating temperature as well as the boiling point, especially of water. So this is very, very much important to mix so that you can be able to achieve the intended temperatures. Thank you for the contribution. If there's a question, we can get it, then we quickly break off for tea break, then we can continue.
Hello?
Yes, go ahead.
Yes, my question is on the difference between PV solar and concentrated solar power. I don't have much knowledge on the concentrated solar power. Perhaps if you can just enlighten me on the cost differences between the PV and the CSP. Which one is more maybe cheaper or expensive than the other, depending on the production? Thank you.
Okay, that's a very brilliant question. So to answer your question, I will give 2 scenarios. For solar PV, you can see that you can do both utility scale and domestic scale. Then within the confines of economic analysis, there is what is called the economics of scale. So for example, for solar PV, if you are doing a small installation, it can be of a few US dollars per kilowatt, because that you find that it will even be actually very expensive if to do a simple solar installation. For example, 2 kilowatt solar system on your rooftop with an inverter and a few battery storages. You find that that one is going to be more expensive as compared to the designing of a utility scale solar PV power plant. You've seen that? That's the economic of scale. Because these guys, the colleagues who are manufacturing these projects, when you buy more, you buy less, you buy at a cheaper price. But if you are buying less, you will reduce the prices so that you can be able to get recovery of the investment. Now, when it comes to the difference in terms of costing, you find that these CSPs, because they are site specific, it becomes difficult to locate those sites. So building of roads, access points to those power plants, it becomes also very expensive. Then also the technology itself, you cannot be able to build a domestic CSP plant. So all these are huge scale, utility scale power plants. Then apart from one of the key benefits also of these systems is that apart from heat production and electricity production, a CSP is also able to carry out water desalination. As you know, across the world, much of our waters in our water bodies are salty Sorry, I'm receiving some feedback. Maybe we can switch off our mic.
I think the noise is gone. Is Elvis, you can come back. Your audio can come back.
Okay, maybe I was muted as well. Am I
Yeah,
audible
we
enough
lost.
now?
Yes,
Okay,
you are.
thank you so much. So I was saying that a CSP can be 3 plants in one. One plant you'll be able to do heat production, then the other part of the plant you'll be able to do electricity production, then the other part of the plant you are able to do water desalination. So the expense of doing a CSP plant is more, and the other scenario I gave is that accessibility to these plants is also not cheap, because you need to construct roads in a, for example, in a desert, for you to transport your equipments when you are carrying out now the project installations. And also the cost of buying technology. This technology is not so common. Capacity building hasn't been done mostly in the areas because this plant is not too much, I can say, fully exploited. So you find that the investment cost is quite higher as compared to a CSP plant. But the key benefit which I alluded to is that you are able to produce electricity even during nighttime. So when you talk of expenses, it's 50-50. It depends on where you are siting the power plant. For example, a utility scale solar power plant can cost, a solar PV cannot cost you beyond 1,000. That is $1,000 per kilowatt hour. Similarly, a CS plant is in the range of 1,500 to 2,500. So it's quite competitive as well. But what is important is the costs and benefits. I'll come and explain later when we come back from the break, when we look at now the costs and benefits of the renewable energy projects. Thank you so much for that important question.
Thank you. Thank you very much.
Okay, now we can break off for the tea break. Our moderator.
Yes, thank you. It seems there's no other hand. Otherwise, we can still solicit input later on after the tea break. So 5 minutes from now, technical team, and we may put up the poster for tea break. Thank you.
Okay.
Welcome back, SMEs. It's 10:46, so we could resume our class. Just check back with our trainer. I'd like to request all participants to keep the videos off. All participants, please keep your videos off. Engineer Nyirenda, we could resume.
Thank you so much, moderator.
Thank you. Mr. Wisdom, please switch off your video.
Okay, welcome back. We'll look at now the planning now. We'll go deep into the planning. What is it that it takes for you to plan for these renewable energy projects, which is B. So now what are some of the things that you need to consider when planning for a renewable energy projects? So number one is site consideration and analysis. You need to consider the site where you need to place your renewable energy project, be it the solar, the wind, the biomass, the thermal plant, all such types, including the hydro. You need to carry out a very, very considerate assessment. Then also available renewable energy resource, you need to see. So for you to quantify, there should be a lot of studies that you can be able to do. You can consult international softwares, for example. Those who are doing solar, you can use what is called satellite resource data, which you can easily procure from Metronome or NASA. Then colleagues doing the hydro, you can start gauging. You can put what are called gauging stations at various points for you to measure the flows in terms of water. Similarly, for a geothermal power plant, you need to put up equipments for you to start measuring the temperatures. And then, for example, a good quantitative period, probably of 2 to 3 years, is suffice you to give you the actual data that you need. Then where you are not sure, even more period is required for you to get a conceptualized resource. Then preliminary resource assessment and correction of resource available over a time period. This is what I've talked about, which is very, very important. And I've given you examples. Softwares are always there. There is Wind Pro, which you can be able to use, and also installation probably of a meteorological stations at various wind sites for you to get the quantified resource data that you can be able to rely on. Then available off-takers. If you are doing a grid-connected solar plant, you need to carry out an assessment. Who's going to be the off-taker? And then how far is it from the nearby substation? And which is the injection voltage? And probably if I come up with this plant, at what voltage am I going to be generating on? So that you can be able to carry out a brief assessment in terms of the costs. Then now we talk about the costs and benefits. This is very, very for the success of the project. You need to know what is going to be the investment cost for this project. Then also, what does it take? What is required in terms of not just capital expenditure? If the plant is up and running, what are the estimated costs of operations and maintenance? Very, very key, because you can start showing on your capital, and when you do that, you find that your project will not be profitable at all. Then the most important thing also is what is known as the levelized cost of electricity. This will give you an indication of how much is it for you to generate 1 unit of electricity, either from solar or from wind or from biomass or geothermal. And this is where now you base your emphasis to say, if I'm probably generating at $4 if I'm probably generating, oh, okay, no, it's all right. If probably I'm generating at $4 per kilowatt hour, how much am I going to be selling this electricity for me to have a probably a payback period, which financials out there are looking for? Because financials and lending institutions will not give you money, which you probably, for it will take you a lot of years for you to return back that money. So an LCOE calculation in any project investment is very, very much important. This is where we need to base our emphasis. If we've engaged an external consultant and is brought a report of the assessment of the energy project, let's ask them, what is the LCOE of this project? Then the LCOE, this is a quantified resource period which takes about the capital expenditure, cost of operations and maintenance, as well as the revenue that is generated from the sale of electricity. So it encompasses everything, including the financial risk, the interest rates, as well as the inflation, which now other people in financial circles, they are calling the discounted rate. So the time value of money is there in the levelized cost of electricity. Then a tariff is achieved in various forms. I'll come and talk about it later in the next subsection. We can move on due to time also. Then renewable energy policies. There are a lot of policies that encompasses renewable energy. As you know, renewable energy in some circles, they are calling them disruptible energy sources, because operators of the grids, operators of various transmission service networks, they were not anticipating these to have variable renewable energy sources to be injected into their grids. So these, they're also skeptical. So now they've provided some guidelines on how now these renewable energy projects are supposed to be deployed. An example is these, they vary on the type of renewable energy project. For solar, off-grid, you may find that it's very easy because you are not connected to the grid. But as you probably expand on the solar off-grid, it becomes a solar mini-grid. And from a solar mini-grid, if you want to reduce on the operation, the cost of operations and maintenance, the utility grid is near, you can easily connect to it. And there you incur other aspects of the policies. For example, some of the policies which includes distribution and transmission grid code, they have to emphasize what is the voltage magnitude in terms of the bandwidth. How does it supposed to behave? For example, if your grid transformers, which are inverters, if they are connected to the grid, how are they supposed to be in terms of voltage bands? The plus or minus, is it plus or minus 10% of the normal standard voltage, and at what frequency is your system, and at what frequency is the grid system, so that the two are able to match? And how is the behavior in terms, for example, when there's a fault, a through fault, or there is a phase fault, there's an earth fault, how is your project going to respond? Then these I'll come and explain more when we start looking at grid integrations, which is also part and parcel of this module. Then we also talk about the national energy policy. Each country has got its own national energy policy. These are the guidelines on how renewable energy projects are supposed to be deployed. I'll give you an example. For example, in our country here in Zambia, we've got a national energy policy of 2008, which stipulates how much in terms of renewable energy do you want to push into the national, at what period, so that you can attain what is known as security of supply and stability of the national grid, so that you can be able to have continuous supply of electricity to come to customers without disturbing anybody and disturbing the economy. Because mind you, any national blackout, huge sums of money are lost, especially from huge manufacturing companies and the mines. And you can be penalized if you are a grid operator, a transmission network service provider, if you didn't plan. Then power sector master plan. This is also very, very key to make sure that renewable energies are able to compete actually with what the already existing traditional energy systems. For example, coal in our colleagues there in Zimbabwe, where they have a lot of coal power plants, similar to South Africa, as well as our colleagues EDM from Mozambique as well. So within the sub-Saharan Africa, we've seen that there is huge consumption of either coal and nuclear thermal power plants from South Africa. So these need to evolve. Then feed-in tariff, very, very, very good policy. In some circles like South Africa, these policies are there. In Zambia, we are still developing this policy so that very soon it can become law, and it will be able to guide SMEs and other investors who are willing to come and invest in the sector. Okay, let me just pose this question. When we talk of feed-in tariff, what are we trying to talk about? Can anybody explain to me who has got an idea? Because this is very, very important, especially for the success of renewable energy projects. Anyone within the background before we proceed?
I would say it's a policy that gives an overview for how renewable energy independent power producers basically feed into the national grid, and it just governs the renewable energy and other project developers with regards to the national grid.
Okay. Very, very good answer. Anyone else as well? Before now, I summarize the two answers.
Okay, yes, yeah. I think the feed-in tariff policy is the policy which governs the pricing, specifically how much the utility is going to buy the electricity from the producers. So it's more like the guideline.
Very, very good as well. So we've seen that this borders more on the investors, either which we are calling the independent power producers. These, like I told you, grid operators were not seeing the effect of renewable energies. So at the point of injection, for example, you've got a solar rooftop power plant on top of your house, and then you are not so sure, all you are interested in is, I want to generate electricity because of these blackouts which are happening. Therefore, if you haven't engaged reputable and competent people to do your design, they can sometimes over design the system such that what you are consuming is very less, then excess power is fed into the grid. Now, that power which is excess, which you are feeding into the grid actually in some circles, there is this policy is there, but this policy as well, it depends from one area to the other or from one country to the other. In some circles, the utility industry will be able to pay you money because you are giving them excess power which they can sell to other customers at a higher fee, and then you agree on how much you can be able to feed into the grid. Then in some circles, like for example, where these policies started way back, and they have seen the effect that if you allow this policy and you allow so many dotted independent power plants to be feeding this power into the national grid, it can compromise, for example, the voltage and the efficiency of the of the independent of the national grid. Therefore, to avoid that, they put a limit to say you can only inject, let's say, a maximum of 30 amps. More than that, the grid operator will not pay you anything. So us, especially SMEs, we need to be very, very, very much careful. Once these feed-in tariffs are established in our various countries, we need to make sure that we abide by them, because these in the financial setup, they call them as incentives. And mind you, renewable energy projects are driven by incentives, because incentives are what lowers the project cost. As investors, you don't need to spend much, but what you want to spend to get in is what? The benefit. So when I talked about the costs and benefits, they apply everywhere. Renewable energy projects is all about costs and benefits, and you need to make sure that you lower the operation and maintenance costs. Is that clear? Did we get that? Okay, we can move on to point C.
Engineer,
Yes.
there are some hands and also a question in the chat for you to repeat the LCOE definition. So that's
Okay.
from Julia. And she still has her
All
hand
right.
up. Maybe she would want to also ask something else. Thank you. There are 3 hands, so maybe we can start with Julia.
Okay, Julia, please go ahead.
I just wanted, sorry, it's just a comment. The presenter is going a bit too fast. We are not keeping up on this end because we also try to take notes while we are listening. If you can slow down, that would help. And then secondly, I just want you to go, just to repeat briefly on the LCOE, as you said, it's very important to note.
Okay, thank you, Julia. Point taken. I'll be a bit slow, but not very, very slow. Then on the LCOE, this is what is known as, by definition, as levelized cost of electricity. And in some circles, they call it the levelized cost of energy. Then the unit for this is it can be in any currency. For example, if you are using US dollars, it can be US dollars per kilowatt hour or per megawatt hour, but the standard is per kilowatt hour. Then if you are, for example, our colleagues in South Africa who uses the land, it can be in land per kilowatt hour. So it's money over the electricity production. Then the formula for this realized cost of energy, those guys who are writing, it's very much important to take note of it. It's called LCOE is equal to the capital or the total project costs multiplied by what is known as the capital recovery factor, then plus annual cost of operations and maintenance, then plus the salvage value of your project, because after the end of the life cycle of the project, you need to get the remains of the project from there, and then you can be able to generate some revenue from there. That's what is called the salvage value. Then all that equation that I've given it, you divide it by the net annual electricity produced, which is in terms of kilowatt hours. So you convert, if it's your plant is huge, it gives you megawatt hours, you convert into kilowatt hours, then you'll be able to get what is called the LCOE. Did we get
Sorry,
that?
May you come again on the formula?
Okay, so the LCOE is equal to total cost are we writing total cost multiplied by capital recovery factor plus annual cost of operations and maintenance plus the salvage value of the project, divide by everything on top, divide by the net annual electricity produced. Did we get that formula, every one of us?
Yes, we got it. Perhaps we might want just one or two examples, maybe later on how you can have that figure, how we can have that LCOE calculated. Just an example, maybe at the end of the session, if time is permitting to you.
Okay, very, very good. So I'll be able to, if time permits, as you've seen, as you've alluded, the moderator, someone to switch off the mic in the background. The time is there, I'll be able to give you, and that's what actually we are missing. If it was
Engineer, I think your mic is on mute. Kindly unmute it. I think it went off while we're muting everyone else. Thank you. And there are two hands up, I believe. Yes.
Okay, please.
We've got Chairman and Luke.
Ncheme, you can go ahead.
I just wanted to know, like, when you were talking about the energy, like the measuring and accessing the wind power.
Anybody that got the question from Nchebe, please give it to me. I didn't get her clearly.
I think, Cheme, if you could speak close to your mic and repeat your question.
Okay, my question is, when you were talking about wind power, you said there's a device or a tool that can be used to measure or assess wind power. What tool is that? I didn't get it clearly. Thank you.
Okay. Thank you so much, Ncheme. I'll give you two examples of the quality tools that you can be able to use. Then I will give you WindPro. WindPro, this is not a free software. You need to buy a license for this software. The software is called WindPro. Then there's another very interesting software which is called SAM, SAM. And this SAM software, all of us, let's take down the name for that software. This is a totally free software which is given by the National Renewable Energy Laboratory of the United States of America. Then this software, you can do designs for both solar PV, concentrated solar, you can do hydro, you can also do wind and biomass as well. So let's take note of those two tools. Then I'll give you a third tool also, which is very much important as well.
Excuse me, sir.
Yes.
What was the second program?
SAM.
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 SAM. Oh, SAM.
SAM.
All right. Thank you.
Yes. Yeah. So SAM, the initials for SAM means System Advisory Model. Did we get that?
We got it?
Yes, we got it.
Yeah. So just go on any website, Google it, SAM, and then it will take you to the National Renewable Energy Laboratory of the United States of America, and then you'll be able to download this software. Yeah, it accepts any data from a geographical location. All you need is push in your coordinates, and then you can be able to extract the data. If you have the data, which is probably you've stored it anywhere, you can easily import it into the software, and you can start doing your designs. I think one session, our moderator, or maybe in future, they will arrange for you guys to start learning these softwares, and I'll be able to assist in that context. We can move on. If there is no any other question, or there was one question remaining, let's get that question.
I think, Engineer Nyirenda, you had mentioned WindPro, SAM, and the third one, which you were about to mention.
Oh, Red Screen, Energy Expert. This one is called Red Screen, RET Screen, then Expert. It's also very important for the assessment of energy projects. This one will give you very quick estimation in terms of the available renewable energy resource, as well as the economic performance of your energy system. This one you can be able to know, as long as you know the cost of all the products that you need to feed into your energy project, and then it can even able to calculate the LCOE. So LCOE calculations in these three softwares which I've given you, is done automatic. But you need to know that formula which I gave you. Don't forget that software. That's the basis for renewable energy projects. Can we move on? Or there is another hand?
I think Luke, your hand is up. If you already asked the question, you can lower it, please. Thank you.
All right. Okay, we can move on.
Yes, we can, I believe.
Okay. Okay. My slides don't seem to be moving. I don't know. Maybe it's hanging somewhere. Moderator, are you able to get me?
Which slide are you up? Are you on right now? What I'm seeing is B.
Yes, I'm on B,
Yeah,
but if
B
I
is the
place
one
next,
showing.
I'm trying to place next. It's not responding. Let me stop sharing the screen. Then I reshare again
And
just for
reshare,
1
yes.
second. Okay.
Yes.
Okay. Okay, so we are now on point C. We'll look at now renewable energy grid integration and impact survey studies. This is very, very important. Like I said, if you are citing a site for the development of a renewable energy project, you need to look at accessibility of land as well as the distance closer to the nearby evacuation point, which is a substation. If you are doing, for example, a solar PV power plant, you need to look at the topographical and the geological survey of your area. Is the land flat, for example? Because solar panels, you need to make sure that they follow a certain uniform pattern. So that reduces the overall total investment cost. So it's very, very much important. So grid integration studies are very, very much important in order for you to assess what I'm going to talk about. So done for grid connected renewable projects. For projects which are off grid, doesn't matter. You don't need to do that. Then carried out as part of the feasibility studies. So if you are doing the feasibility study and you've not carried out your grid integration study, that report, they will render it useless. No one will be able to approve that, because when you carry out the grid integration studies, it will talk about, for example, harmonics. What level of harmonics are you going to be injecting into the national grid by establishing that renewable energy projects? Then if there is a fault in the system, an earth fault or probably a line-to-line fault, how is the system going to respond? Or for example, if there is a sudden loss of your power plant, at your plant, the faults happen. For example, you lose one of the turbines. What is going to happen? How is the grid going to respond? Is the grid going to lose some power so that customers are able to be affected? So all that needs to be tabulated correctly using some software tools, which I'm going to give you later on, just within a few seconds. Okay. Then these are necessary to know the impact of the interconnected power system. Then the impact on the renewable energy project itself when subjected to unstable conditions, which I talked about, loss of synchronism at a power plant, as well as loss of a bigger load in the IPS. So meaning that, for example, you have got, I'll give examples to our colleagues, for example, in Zimbabwe. When you lose the entire Wange power plant, what are the consequences? For example, massive load shedding. So now, because there is massive load shedding and the grid response is not within minutes, is within seconds. So you need to know if there is this loss of a power plant, how much load do we expect, so that the grid operators are able to respond within a very short time so that there is no national blackout. That is the loss of the machine. Then loss of the load, for example, a bigger mining loads. You've lost one of the power plants, for example, in South Africa or within Mozambique or within Namibia. How is the system going to respond? And because all of us, we are within SADC, we have what is called the Southern African Power Pool. This is very, very much important. What we notice here in Zambia is exactly what our colleagues notice in our neighboring countries. So if there's a huge disturbance, for example, EDM, when they lose the synchronism at their high voltage DC transmission network, you find that there's turbulence in our national grid. Sometimes even our machines, our generators in Zambia, they trip. Wange power plant also trip. Now, if you also come up with your renewable energy project, you put it there. So you need to use specialized tools software to simulate the actual scenario. How is it going to perform when these conditions are able to be met? Then experts are able to be consulted for these. They are able to do some simulations for you and then will be able to issue with a report which will speak to all these, so that when you present it as you, a project developer, you want now to present this either to an off-taker of that, you'll be able to read that and you call on experts to tabulate and also scrutinize what the consultants were able to achieve. And from there, if they say, okay, this is good report, and the works which were done are being backed up by international regulations. For example, the N-1. N-1 means, for example, if you have a power plant, there's a standard that you don't need to have only one evacuation line, for example, or one evacuation transformer. You need to have two, so that if one is as a fault, you can rely on the other, so that there is continuous supply of electricity to the customers. So this report talks about how stable your energy project is going to be. Then these are carried out using international recognized software. Some of the softwares include Power Factory. This Power Factory software, we can call it, is now the software of choice within the SAP region, the Southern African Power Pool. For example, ZESCO use this software. Eskom of South Africa, they use this software. NamPower of Namibia, as well as the ZESA of Zimbabwe, they use this software. Similarly, so Power Factory is normally used for studying the transmission network. You can fuse in a few power plants, but they will not be too much into details. Then there are two also softwares which are known as PSSE, Power System Stability Expansion Plan for studies. Then there's also Plexos. These two softwares, PSSE and Plexos, are very, very much important, especially when you are doing what is called grid expansion studies. And by the way, if you are doing large scale renewable energy projects, like I said, you need to carry out those simulations. So your consultant will be able to use one of these software tools for them to give you a detailed report which will speak to your feasibility study. Any questions before we move on?
Okay, thank you so much for this interesting presentation. My question is, like these softwares that we have mentioned, are they free or one can subscribe to access them, especially the ones that we have mentioned just now?
Okay. Thank you so much for that question. So these softwares are quite very expensive. Then the grid operators are the people that are authorized to have these softwares. Because, for example, Prexos, the license for Prexos now should be about 180,000 US dollars, maybe for 5 years or 4 years, depending on how you sign the contract with these software developers. So, in a nutshell, these softwares are used by either grid operators or generation station operators and not an individual. So for you who are SMEs, all you do is you need to engage an international consultant or a local consultant who's being able to be trained using these softwares, and then he can be able to collaborate with stakeholders from these utility companies. Because before this consultant does any work, he is supposed to extract from the already existing model which is within these softwares. This model, when I talk about the model, this model depicts the existing infrastructure in a utility company. For example, Eskom South Africa. This software has got all the connection links, has got all the existing hydro power plants, all the existing nuclear power plants, and all the existing renewable energy projects, being it wind and solar. Then, for example, you are coming up with a geothermal power plant. So this consultant, what is going to do is get that model which has got all those, including the transmission lines, and is just going to include only the geothermal power plant for that particular period of time, and then is going to study how that power plant is going to perform within a short and long-term planning horizon. Did we get that, or it's too much into detail?
No, we get it very clear. Thank you.
Okay.
Yes,
Thank you
no,
so
it's
much.
very good.
Okay. Is there any question before we move on? Okay. So if there's no question,
Yes.
yes.
It's just a comment that maybe at the end of the presentation, if you're able to edit this PowerPoint and then include in some of the links to those sources. I see Ms. Cornelia is sharing with us some of those, but also maybe if you can just add them in those specific or related to a specific slides or slide that which you are talking about.
Okay. All right. Thank you so much. I'll be able to send through probably just maybe one-page document as feedback to what we are getting from different participants and through the moderator, and then probably we'll be able to share
Okay.
with all the participants. Yeah.
Thank you.
Okay, so we can move
Hi,
on.
so I have a
Yes.
question, engineer.
Yes, please go ahead.
My question is on this presentation that you have given us on the grid integration, is it only focusing on large scale, or it also focuses on, let's say, small scale? Because the reason I'm asking is there a way that one can integrate like a grid connection system, but they're not really selling power to the grid, but just for the purpose of maybe reducing the cost of buying electricity units at their local place? Maybe it can be at a school or it can be at a clinic. Thank you.
Okay. Thank you so much for that. So for yes and no. So for large scale utility power plants, yes, you need to carry out the grid integration studies. It's a must. For smaller systems, these smaller systems are governed by what we already looked at, the policies. And I gave you one critical example of the policy, which was what? Feed-in tariff. So, for example, if you are in a country where feed-in tariff is not yet established, the utility grid would tell you that you are not allowed to connect your system where? Into the national grid until such a law is established. Then if you want to lower your costs at home, this is now where I'll introducing a new term called a net meter. A net meter is a bidirectional energy meter that is able to allow two power flows to interface and then give you an intended energy output from there. So meaning that you've got a utility, or if you are buying power from ZESA, that power comes through your meter, and then you've got a rooftop solar. You want to reduce on the cost. That rooftop solar will also go through the same meter. Then the meter is going to do a calculation of plus or minus. Then that's what you are going to be paying as an electricity user at your locality. So that meter is also very, very important. But how does this meter comes in if feed-in tariff is already in place? Did we get that? Very, very important. So you need to consult, especially with your local guidelines where we are located, all of us. Especially, are we allowed to feed into the grid? Or if we are not allowed, how do we benefit, for example, to avoid massive load sheddings? Even when we've seen that solar panels are becoming cheaper, also inverters are becoming cheaper, which we can be able to get and procure. But should we connect them to the utility grid? Proper consultation needs to be found out, especially from the local distribution operators, and also the guidelines from our Ministry of Energy in various departments, and also the energy regulators. Like, for example, in Zambia, there is what is known as Energy Regulation Board. These have got guidelines on how you can be able to consume these products. Are we clear on that one?
Yes, I think I got it clear. Thank you.
Okay.
Is there, Nirenda, we have a hand from Sandhya.
Okay, Sandhya, please go ahead.
Hi there, sir. So thank you. So very knowledgeable. I have a software company and I've built software solutions as well for like solar energy, utilities, and many other software solutions. Who would you say that is the person that I need to get in touch with to offer the software solutions that we built for utilities?
Okay. Thank you so much. So for solar, there are internationally recognized softwares. I'll give you I think two. For now, there are quite a lot that I'm able to interface with, but I'll give you two for now. So one of the most recognized softwares which you need to know as a solar installer or a solar power designer is what is known as PVSYST. PV in caps, then small letters YST. PVC software, this software is developed in Europe, and it's being recognized worldwide as one of the major softwares which designers and developers are able to utilize. So if you consult PVC, just Google that word PVC, and then you can be able to download a free version for 6 months. They'll give you a free version for 6 months, which you can be able to start utilizing to do some designs. Then there's a paid up software which you need to pay. It varies on the users. For example, if in your company, if you've got 5 users, the price will go slightly up. And there's also a price for students. So students don't need to pay too much for this. It should be about 250 francs. That is for 1 year. So this software was developed in Switzerland. So that's why you've seen even the currencies are franc. Swiss franc. You pay that and then you utilize it for the next 1 year, and you can renew the license depending on the usage. So international organizations, they certify your design if you have used PVCs to say yes, this is a good software because it has got within it embedded solar resource data from different providers, NASA, Metoname, PVGIS. All this data is loaded within the software, which you can easily download just using the coordinate system, and then you'll be able to carry out your design. Then another software is called Helioscope. Helioscope, like helicopter now, Helioscope. This software is developed in the United States of America. It's actually more advanced and mostly used for off-grid and also rooftop connected systems. This software, it has got the embedded other softwares like SketchUp, Scallion, as well as Google Earth is also there. You can be able to do your designs within a very, very short period of time, but this software is very, very expensive. Just for you to acquire a license, it will cost you probably not less than $900 for 1 year. So as an individual, sometimes it becomes expensive, but as a company, if your company grows, because this time around we are SMEs, but once we evolve, we become huge companies, we can be able to purchase these softwares and we can be able to utilize them. Does that answer your question?
Yeah, definitely. Thank you so much.
Okay, all right. Moderator, do we have another question in the background before we move on?
Well, that I can offer them because I've got my.
I didn't get that.
I think moderator Sanvia seems to be saying that he also has some software solutions. So maybe he can give his input.
Okay, go ahead, please.
Okay. Sorry, sir. Yeah, we have the scope. I have my vision. So I'm just looking for maybe people that you can refer me to from governments that I can introduce to, any departments in country that I can introduce the software to, because I've got my own software.
Oh, okay. On that one, probably maybe you can make that request through our moderator, and then they'll see how consultation and how they can be able to take that up. Thank you so much, Sandhya, for that question.
Okay, thank you.
Just to add, Sandhya,
Yes.
you can write to Cornelia at SACRI, the facilitator of this program. Then she'll be able to connect you to us or relay the information to us. Then we can connect with the utility here for your marketing of the software.
Okay, 100%. Thank you so much. Appreciate it.
All right. Any other hand? Questions?
Don't seem to have any other hand.
Okay. Thank you so much. So we can proceed to the next point, renewable energy tariff design. So tariff design, I think I've talked about it in the other context. You see the content of this. It's not too much, but it's very, very important. So this is designed using the system cost of the project. So meaning that the reference point, once you just talk about total cost of the project, what should come into mind is what? LCOE, which talks about the cost of operations and maintenance. Then now, because you yourself as a plant operator, you've come up with that plant, the renewable energy plant. Before you start selling your power, there is going to be need for the transmission charges. So the grid operator who's going to charge you, say, okay, you are generating 10 megahertz. For you to transfer, us to transfer your power into our network, we are going to be charging you this much. And there's also what is called connection charges. Apart from connecting charges, if your regulators also, they will say, okay, you need to pay a certain percentage as a production cost once your plant starts making money. So these charges, you sum them up now. Once you sum up all the charges, then also you total it with what? Your LCOE. Then now you agree on a tariff, because tariff is mutually agreed by the purchaser through what is known as what? The power purchase agreements. You need to agree so that it's a win-win situation where we are talking about a willing seller as well as a willing buyer. So that has to be agreed and at a certain period of time. So all these are constituted in what is known as a PPA, power purchase agreement. And for your project to be bankable, so that everything is met, the grid impact studies you've done, I'll explain, I think the next slide, I'll explain the other parts of the project that need to be done. A PPA, once this is signed, even as a project developer, you even feel happy that yes, I've achieved this. This is how much I'm going to be selling power to the customers. And the financials, I should say, they'll be very, very much interested to see that very, very much important document. And these PPAs normally are very, very confidential. As an individual, you will not be able to go, for example, to ESCOM to say how much power or how much are you selling power to this consumer. They will not give you that because it becomes a legal document after all. Then others, you talk about the interest rates, the inflation, and the economic risk. I'll talk about the interest rate and inflation. These two, they form that component which I talked about in that formula called the capacity recovery factor. So capacity recovery factor is a component which constitutes the interest rates as well as the inflation, because these two, this is what forms the time value of money, which is the discounted rate. So this discounted rate is discounted for a certain period of time. For example, the renewable energy projects, most of them, solar, you may find that the life cycle of the project maximum 30 years, but the economic value is 25 years. The inflation also, how much is it? For example, how is your currency performing and everything? They are also factored into that discounted rate. Then economic risk, very, very, very important for renewable energy project. As a developer, you don't need to invest in a country which is chaotic, for example, or in an economic environment where you know that this off-taker, for example, there will be no paying you money when you supply electricity, or there is unstable conditions, for example, civil wars, turmoil, people are just doing something that is making the economy not stable. That thing, once the lenders of the monies hear about it, they will not be able to give you money because they will know that maybe probably after you construct your plant is going to be bombed. So it's very, very much important to consider the risk when you are doing renewable energy projects. Then we'll come and talk about later on the stakeholder engagement, which I'm talking about now, which is very also much important because in some circles they've never seen solar panels. Like an example which happened in India, in one of the provinces down south, Chennai. They had to put up the solar plant. Then what happened? The local community started destroying the solar panels. So there was no proper engagement of stakeholders before that plant was done. Why were they destroying that power plant? Because sometimes the social aspect comes in, the beliefs, cultural beliefs, to say, no, us here we worship the sun, in terms of the region, but why are you doing this which is capturing the sun energy? So people need to get rooted. They understand the economic risks before they engage into the development of the renewable energy projects. Then the revenue generated from the sale of electricity, very much important as well. So when we talk about the revenue generated from the sale of electricity, when you carry out your simulations or your designs, this plant need to give you what is called the capacity factor. This capacity factor is very, very much important. This will tell you the total, especially the total estimated annual electricity that is going to be produced. This electricity produced eliminates the system losses, eliminates also the local consumption for your what is called the auxiliary power supply. Sometimes, for example, in an hydropower plant, you need water maybe for cleaning your coolers, water for providing domestic consumption to the workers, for the toilet, and then you'll be having some pumps running, also some drainage pumps to pick up the water from underground there so that you don't submerge your power plant, so that the plant is kept dry at all times. Then there's going to be that electricity which is going to go there, which we are calling auxiliary supply. Then you need to factor all those aspects. Then you know the net. That's why when I gave you that formula, I said the net annual electricity produced. It's a net, excluding all losses, excluding all the power that is going to the auxiliary consumption, so that you can tabulate what is known as the levelized cost of electricity. Then the life cycle cost of the project, you need to know them. You need to make sure that you reduce on the cost of operations and maintenance. One of the key areas where you can invest in probably is automation. You can automate the process so that you can cut down on some of the costs. Yeah. Any question before we move to the next slide?
Okay, I have two questions, engineer. The first one relates to the issue under renewable energy tariff design, especially on the economic risk. I wanted to understand that since the economic risk is associated here, as you have indicated, with very qualitative factors, like is the country chaotic, are there any unstable conditions, civil war, etc., etc. How is this measured and expressed in quantitative terms?
Okay.
Then,
Thank you.
The second question was going to come probably at the end of the presentation, but I'm not so sure if I can just bring it here. I wanted to understand a little bit more about sensitivity analysis.
Okay.
The reason why I'm asking is, for example, I have a project, and the institution that is standing in between us and the investors are requiring that a sensitivity analysis should be performed. So I wanted to understand, in terms of renewable energy projects, what are some of the factors that are critical where sensitivity analysis are to be performed and reported?
Okay. A very, very important question. We need to take note of that question, and the answers I'm going to give you, they are very important for the success of your project, especially to get financing. So we'll talk about the economic risk. These values or measurable factors which are quantitative. In scientific terms, I should tell you there is none. That's the reason why even in the discounted rate, or they call it the time value of money, they only consider interest rate and inflation. But economic risk has also a huge impact on inflation. So you find that, for example, the country will start deteriorating the expenses, the GDP will not be performing well, especially when there is economic risk. Then the other, especially us who are developing renewable energy projects, the point of contact, especially when you start engaging stakeholders. I've got this project, there is this one. What you need to make sure you avoid at all cost is that you do what is known as, the moment you start contacting, for example, utility companies or what, you do what is known as a non-disclosure agreement, an NDA. This will give you guiding principles so that you eliminate noise, you eliminate other people who may want to influence your project. And also, what is most important is that you don't do these projects, because these projects are capital intensive. You don't do them without the involvement of key stakeholders. So some of the key stakeholders include political leaders of high influence. So for example, you should be able to go where, for example, the Ministry of Economics, the ministry who is in charge of energy, you go there until you get all your certifications in these, then you avoid that risk. The moment you are going to approach your utility, who's going to do your grid impact studies, they will require also these documents. Did you get clearance from the Ministry of Energy? Did you get clearance from the Energy Regulation Board? Is your company registered? Are you a taxpayer? So that all those, you eliminate them, and then you'll be able to achieve your intended target. Then when it comes to the sensitivity analysis, sensitivity analysis in most renewable energy projects is done between plus or minus 15% of the following aspects, which I'm going to talk about. And these three aspects especially, they talk to the tabulation of the LCOE. So an investor, you should be able to know, I've done the absolute value, what is the maximum and what is the minimum I can go to get my LCOE within what? Within a profitable margin. So you can look at the interest rate. So you'll be able to say, okay, my interest rate is this. Then how is the LCOE at 5% plus and at 5% minus? Similarly, at 10% and minus 10%, at 15 and minus 15. This is well accepted. Then you also cut out the inflation in the same manner so that you can be able to avoid that. Then you also now cut out the sensitivity analysis on the LCOE itself. Plus or minus 15% is acceptable to cut out the sensitivity analysis. Did we get that?
Yes, I got that. Interest rates, inflation rates, and you indicated it should be between minus 5 to 15% plus or minus. I'm not so sure if there are any other factors that can be considered.
Yes, that's the thing. Then you also do it on the LCOE itself. And then that will guarantee, even the investors, once they look at your report, you've done that, they will know that this guy, he knew what this was supposed to be done. So when you now engage, because when you are doing these projects, you don't just look into one direction to say, I'm going to engage a consultant to do grid integration studies. If you are not fully conversant with financial or economic modeling of your project, you can be able to engage an expert financial modeler who are going to do the financial model of your project with all the life cycle costs, the payback period, operation period, life cycle costs. They tabulate everything, including the sensitivity analysis is supposed to be done within that report which is going to be given to you. Thank you for that question. It's a very important question when you are looking at projects, especially renewable energy projects. Any question before we move on?
When you deal with this country risk, what
sort of instruments are available to you to mitigate maybe country risk or to lower the cost of implementing a project? And what type of institutions maybe would we be able to approach to provide bid guarantees or anything of that matter that can help to resolve issues around country risk? Unfortunately, within Africa, in Southern Africa as well, country risk seems to be a factor that always increases our cost of delivery.
Okay. Yeah. So when you are doing these projects, one of the major risks also includes the source of your data for your project, because when you engage a consultant, probably will underestimate how much electricity you are going to be producing. For example, if it's an hydro plant for the next 50 years, and he also overlooks the cost of replacement of, for example, your turbines and your transformers. So you need to make sure that you engage highly reputable, internationally recognized and certified organizations to carry out due diligence on the equipment that you are able to procure. Transformers, you need to do those tests. Similarly, you need to do tests on the cable so that you can get qualitable equipment, so that you eliminate a huge chunk of the financial risk which you are not sure of, as the plant is going to be operational for a longer period of time. So probably those on a technical side, that's what you are able to consider as your risk. That's the reason why if you are engaging stakeholders and also employees, you need to make sure that competency is there, knowledge transfer is there, as well as capacity building program, so that you constantly keep on training your employees so that they can better the life, not just of your monies that you are getting, but of your equipment as well. Then also other issues that you need to look at is certification in terms of, for example, fire risk. What do you need to put in place if there is fire? Also, insurance costs need to be there. So the plant in total is supposed to be secure almost from all the factors. Quite okay, human error is there and there, but we need to make sure that this is reduced using training and capacity building. Thank you so much for that question. Any question?
Okay, thank you so much. My question was just maybe to say, is it possible that we may do a calculation, an example calculation for this LCOE, especially soon after this renewable energy tariff design? So I was just thinking that if it's possible, we can have an exercise or something that will actually help us to just have like maybe an appreciation of how it can be calculated, and also like what you mentioned, that maybe sometimes we would need to engage a financial expert in other big projects, but maybe for this one it will be just to appreciate how it is calculated. Thank you.
Okay. Definitely. Moderator, I'm sure we've taken note of that. Maybe at the end of it, we'll be able to do one example. I think I've got some examples, but we can be able to look at one so that I can take them through the appreciate request.
That is fine, engineer.
Okay. Thank you so much. Okay. Any question before we move to point number E? Okay, if there's no question, we'll move on to point E. This is a continuation of D, but it's not too much, just a short period of time. So revenue collection for utility scale. So revenue is collected as agreed in the power purchase agreement, which I talked about. It's a unit cost of electricity, or the tariff, which is in US dollars per kilowatt hour, or in whatever currency is applicable within the confines of our localities. Then also standard energy meters are used, international certified meters, so that metering, most of the people, they overlook it. It's a very important department which can be created within the organization once your organization grows, because the security and the sensitivity of your meters, that's what you are going to be getting. They say it's garbage in, garbage out. So your metering is supposed to be up to the standards so that you can be able to get the intended units, and then you bill your customers from there. Then for off-grid and mini-grids, the project developer is responsible to negotiate a tariff and revenue collection mechanisms. So if you are doing off-grid systems, for example, you are giving supply to a local village which is not connected to a grid, you need to negotiate on the tariff. How much are you? But you don't need to overcharge the people. By the way, like I said, it's a willing seller, willing buyer. So you need to look at the local guidelines also. How is the tariff generated for locally produced electricity in off-grids and in main grids, taking into consideration the levelized cost of electricity as well as the cost of operations and maintenance, which is very minimal to a project, especially for smaller projects. Then some of the costs, which include wheeling charges, are also agreed in the power purchase agreements. Wheeling charges, these are the costs, for example, which you as a project developer are able to incur as you are using other facilities, especially the transmission network of, for example, the transmission service provider, for you to transfer your power from your power plant to the customers. So it's very much important, and this constitutes the power purchase agreements. I think this one I talked about it even earlier. So we can now go to point number E, services which you need to do on a large scale solar PV projects. So these services, I've said, they include the following, but they are not limited to the following. So proposed and new plans, that's number one. Site analysis need to be carried out. You need to do the geotechnical studies. So these studies, they are specified consultants that you can be able to do. Geotechnical studies, they need to carry out the proper topographic surveys, and also how is your plant going to sit on the available land that you have provided. Then also the cost of land, I should say, quite okay in Africa, land is not too expensive, but it's becoming expensive every day because of the population growth. So meaning that for the security of your supply, land needs to be what? Analyzed properly and secured. Fencing, everything need to be done. Hydrological studies, if your area which you've provided has got some streams within it, also studies need to be done. Soil samples need to be taken for testing so that they certify that within this period the land is going to be stuck together, nothing is going to collapse, because it's not good you provide huge capital to produce a power plant and then you find that you damage the equipment within a short period of time, because the guys who are doing the geotechnical and hydrological studies did a bad job. Or seismic studies, these studies are also conducted so that you can be able to determine, is this area which I'm developing the plant, is it susceptible, for example, to earthquakes and also earth movements, so that you don't damage the plant. Then bankable financial modeling of the power plant and system designs. Financial modeling, I've talked about it. System designs, yes, I've also talked about it. I've given you examples of softwares that you can be able to use as well, so that you can be able to do a design of the plan. Then for the existing power plants, you can carry out advisory services like training of staff, on qualitable maintenance practices, providing guidance on the certification of equipment, etc., etc. There is quite a lot. It depends as well on the type of the equipment and the plant which has been installed in that locality. Any question before we move on? This is straightforward. Point
okay,
F.
sorry. Okay, sorry,
All right,
I have a
thanks.
question. Yes, you mentioned something on mini grids to say maybe to put a mini grid in an off-grid maybe community, and you mentioned something about the PPA. So my question was that when you talked of willing buyer and willing seller. So in that case, who is going to be signing the power purchase agreement? Is it the community, or is still with the utility, between the power producer and also maybe the utility?
Okay, thank you so much. So who's going to sign the PPA? Definitely number one person that is supposed to sign that PPA is you, the power producer, and the consumer. Then consumer also differs. You may find a consumer who's a distributed operator or is a distribution operator. You have got this mini grid, or you've got within the mini grid, your role is just to provide electricity. Then there's an independent company that is supplying power to the local customers. So you need to sign a PPA between your local distribution operator and you who's supplying that power. Then the person who's supplying the power to the local community is just going to get what? Revenue. There is no need to sign a PPA between him and each individual customers. Did we get that?
Okay. Yes,
Yeah.
but like the question I posed was because you had mentioned that you do not need to overcharge the customers. So I was saying that maybe you are dealing with a community, a rural community, which might be in terms of their income, it will be low, but at the same time you want to offer them with electricity. So my question was also like in that case, what could be the thing? Should it be something that you need to do a feasibility to see if or market survey in the community to see how much they would be willing to pay, or it's just that something that you just impose to say maybe for the feed-in tariff we are talking of maybe 12 cents per kilowatt hour?
Okay. Thank you so much. Actually, you've answered that question. So a market survey is very important to do, as well as you follow the local guidelines from the regulators. These regulators, like the energy regulation boards in every country, has got guidelines on how a developer of a power plant which is off grid is supposed to supply to the customers. And also the tariffs are also embedded in there. Then even if those tariffs are there, but you need to carry out a market survey and you agree the will for the person who's going to buy electricity to say, okay, colleagues, my LCOE for this plant is this. Then I spent so much money to do a local distribution network. So if I consider all the costs, the only monies which I can be able to charge you is this in this range. So do we agree in this range? If they say no, then you agree on an equitable price where you can be able to sell your power. And mind you, these agreements are done before the plant is constructed. Just imagine you agree, you construct the plant already, and that's when you start negotiating the PPA. What is the risk there? Anyone?
Obviously, the risk is that you may not be able to sell or to agree on a price that will make the whole venture profitable. So these are some of the things that have to be agreed well before the project has commenced.
Very good. Exactly. And this is why it's a financial risk, because even money lenders will not be able to give you money if they've not seen the power purchase agreement. So this is a very, very important document that needs to be done. As you are doing the feasibility studies for the renewable energy projects, make sure that once all the studies are done, PPA is the final issue and you need to agree. You sign the PPA so that you are covered, and then you can be able to get financing from the lenders or any financing either from Iron. Iron actually suggested that they also provide funding actually. So that's it. Yeah. Thank you for those important two questions. Any questions before we come to this slide? For the next slide, I should say.
So Malama, you can proceed.
Okay, thank you so much. My question is a bit, okay, not too off track, but I wanted to just inquire on a product that's along the, I think here the conversation is based on power, but as we all know, at times there's renewable energy products like biogas, which are also produced somewhere along the value chain. I was just keen on finding out if the same applies to the pricing mechanism for, let's say, biogas products, that are produced along the value chain, let's say bottled gas and the likes. Is it okay or is it feasible to take the same approach when coming up with a proper pricing mechanism for a target market, as they say?
Yes. Thank you so much.
That a lot of, I think in some engagements, you find that not really power purchase agreements, but a lot of financiers usually request for off-taker agreements for any particular product like biogas also. So what's the best way of also approaching the same? Thank you so much.
Okay. Thank you so much. So within the confines of different countries, I'll give you an example like Zambia. We've got two very much important institutions. So one is the ZABS, Zambia, um, where they are doing what? The certifications. So your product, first of all, needs to be certified by ZABS that you are producing a qualitable product that meets the standard of being gas or biogas which we are going to be supplying. Then you go to the Consumer Protection Association. So these now they have guidelines as a basis. Where do we start from? Because those guys are able to protect who? The consumers. So they don't want consumer exploitations. So you need to consult those guys to say exactly, me, the investment was this. I think I can be selling at this much. Then they will retrieve documents because there's been some other, these technologies have been evolving. They've been set guidelines such that once you sit down with them, you follow what is written there, and then you'll be able to be guided. Similarly, in other countries, let's look out for those organizations, and then they'll be able to guide through. Even renewable energy. You see, gas, it's on a smaller scale because it's biogas, but it's in the same category as the petroleum industry because that's gas as well. So they've got all these categories and they've got initial pricing in which these things are supposed to be consumed. So regulators, law enforcement agencies, we need to follow them and we see exactly the guidelines where our energy projects are falling. Malam.
Engineer, I would like to maybe with guidance from the KJRTC team is that we're supposed to finish with this training at 12 and now it's past the time. I just wanted to find out how much more of the slides do you have and maybe the KJRTC can advise. Thank you.
Thank you so much. We are just remaining with one slide, then we are done.
Okay, maybe further to that input from Cornelia, Engineer Elvis. So one slide, yes. Then there are those calculations that the participants have asked for. So if we add that, how much time do you think we can allow for?
I think maximum 25 minutes will be done because of the calculations, and I expect maybe some questions as well.
Okay. So from our side, Cornelia, we are fine with that, except you could also comment. If need be, we can still, if we have to stop, we can still bring back Mr. Nyirenda maybe tomorrow for the calculations, or we still do them today. It's up to, I think, Sakri, and Sakri can advise.
Okay, thank you for that, Mr. Musuka. I think it will be advisable that the calculations is suggested that the formula also be written on maybe on an A4 document, and then the examples could be posted there, and maybe we can bring back Engineer Miranda for another time to explain the formulas. I think just to make sure that we keep to time.
Okay.
Yes.
Agreed.
Okay, so if I get Cornelia right, the calculation example, Engineer Nyirenda, you can tabulate it on some text, maybe A4, then you share with us, we'll put it on the e-campus, but still, we'll bring you in, say at some point tomorrow, we'll discuss with the presenter for tomorrow if we can give you 20 minutes and agree with you the time. And we'll announce to the participants. Yeah. So maybe then we can end with the slide that is remaining. Thank you.
Okay. Thank you so much.
Cornelia, you have a hand?
I'm done. Thank you.
Thank you.
Okay. Okay, so we can finish with the last slide. Effective community engagement strategies and effective collaboration. This one I summarized where I talked about stakeholder engagement, very cardinal. Point of contact differs from project to project as an assessment is needed. Examples include traditional leaders, the headmen and chiefs, the landowners, and the political leaders. All this I talked about. But this is not a systematic order in which these things are supposed to be followed. They differ from one area to an area. I'll give you an example. We are trying to cite a site for in one of the cities in Zambia. We first of all went to the chief. So the chief started blasting at us to say, me, I'm just a stakeholder. I'm not the owner of the land, but that's the chief. He said, first of all, go and discuss with the headmen. After the headmen have agreed and the like, then you should come to me for land consent. So these, they differ, and you need to find out, and you need to be aggressive and humble enough, because land nowadays is becoming a huge challenge. And political leaders also, you need to engage them amicably. And then there are costs towards this land. The land costs, everything, you need to make sure that you follow them accordingly. So thank you so much for your attention. These issues, I think I talked about them already. Unless there's one or two questions before I hand over to the moderator. If there's no question, thank you so much for participating and attending this module. I hand over now to the moderator. Thank you so much.
Thank you. Am I seeing a hand from Navan?
Yes, you are.
Please go ahead.
Thank you. Mr. Engineer, I'm not too sure if this might differ from project to project. Can you probably give us some guideline how to make the project more, let's say, attractive for potential off-takers in us being able to obtain a PPA?
Sorry, I didn't get the question correctly.
Can you hear me?
Yes, I can get you.
Okay. So in trying to make the project more attractive to a potential off-taker, how can we increase our chances of acquiring a PPA? How can we, how can we make our project more attractive for the PPA?
Thank you so much. So most off-takers, what they need is surety in terms of sustainability, that is security of supply. So if the technology that you are using, number one, is well vested and recognized, certified by international bodies, that one will guarantee that definitely you should be able to go into a PPA with the off-taker. Then also you need to carry out the market survey in detail. Is that off-taker also has the ability to pay you the money? It's not just looking at how attractive it is, because your project can be attractive, but there's a financial risk. So on both parties, you need to weigh the situation. Then also the other aspect, you need to make sure that it's the skilled manpower that you've employed. Are they safe within your custody? Are these people well trained so that when these stakeholders who are probably the potential takers, they look at you, do they have a reference to say, okay, these colleagues, because they are looking at these renewable energy projects which are quite new on the market, are they going to be interested with the skills so that there is security of supply? And also your financial sustainability. If you've borrowed too much money in your time past and you failed to pay back, probably there will be these off-takers will be so skeptical to say, are these guys, even if we are dealing with them, they are not so stable on the financial scale. So you need to make sure that there's a clean balance sheet within which you can be able to present to them, as well as the financial model will be able to speak to you. Yeah. Thank you so much for that question.
Thank you too.
Okay, over to you, moderator.
Thank you very much. Seeing that there are no more questions, we'll be closing the session. But let me, first of all, ask Cornelia to give some remarks.
Thank you very much, Mr. Musuka, and thank you, Engineer Nirenda, for your facilitation today, and really also thank the participants that it has really been an engaging session, and we really encourage that we learn from each other. Maybe before we close, I'll just kindly request all of us to kindly put on our video so that we take a virtual group picture just for records keeping. And after that, then I'll then hand over to KGRTC to close the session. So kindly put on your videos, and I'll also ask the colleagues at KGRTC and the SACRI colleagues to also take screenshots. So a minute for everyone to put on their cameras. Thank you. Okay, I will be taking a picture now. So 1, 2, 3, you can all smile. Okay, and Andrew also assists please with the screenshots since you're the IT guru.
Andrew, did you get that?
Okay, one last time.
Yes, I did. Go ahead and have one.
The screenshot.
Okay, thank you. Andrew, did you get that?
Yes, I did. Thank you.
Okay, thank you so much. Over to you, Mr. Musufa. Thank you.
Thank you very much, Cornelia, for those remarks. And indeed, I agree with you. It's been a very interactive session and very well sitting for the first session. So we proceed then tomorrow with session 2. And tomorrow, the focus will be on, let me just quickly refer to the timetable, project conceptualization, scoping, technical procedures, and quality assurance requirements. And let me just also state that the assignment, which is due for submission anytime up to 21st July, has been uploaded on the eCampus. And tomorrow, as we start, at 9 hours, we'll give the first 5 minutes to our technical expert, Andrew, to just give a guidance on how to upload the assignment once you write the response or the essay on the campus. So the first 5 minutes will be for that guidance. Then we get into the module 2. Thank you very much for the participation. I look forward to another fruitful deliberation tomorrow. Thank you. Good day, everyone.
Thank you. Bye.
Thank you.
Thank you.
Bye. Bye. Thank you.
Thank you very much. Bye.
Thank you.
Thank you. Bye.
Thank you. Bye.
Thank you. Bye.
Thank you.
Thank you.
Bye.